Alright, so in this video, we're going to be taking what you guys learned as far as finding characteristics of graphs by hand, and we're going to take those characteristics and graph them by hand. So we're looking predominantly at what we can do with graphs of rational functions if we don't have a calculator. So the first problem that we're going to work with is y equals x squared minus 3x plus 2 divided by 4x minus 12. And I know you don't have this sheet at home, but you can write this on notebook paper and still kind of organize it the same way. So first I'm going to get the things that I can get from the regular equation. So I can find my y-intercept, and I know my y-intercept is negative 1/6. And I can also figure out if I have a horizontal asymptote or not. So if I look at this, I have x squared over 4x, and that tells me that I do not have a horizontal asymptote, but I do have a slant asymptote. And so I'm going to go ahead and do the polynomial long division to find that. So I have a 4x. I want that to multiply by something to get an x squared. So that means I want to get rid of a 4, and I want to get a 1. So I'll put a 1 on the top. To get from x to x squared, I need an x there. So 4x times 1/4 x is going to give me x squared. 1/4 x times negative 12 is going to give me negative 3x. And then I'm going to go ahead and draw my line and change my signs. So I get 0, 0x, and 2. And then if I have a 4x and I want to get to a 0x, I'm going to multiply my 4x times 0. And then 4x times 0 is 0x. 0 times negative 12 is 0, and I still have 0. So that means I'm done with my slant asymptote. And so the slant asymptote is y equals 1/4 x plus 0. You can leave off the plus 0 if you want. It doesn't actually need to be there. And now I can go ahead and do the part where I find everything from the factored form. So I have two numbers. I'm multiplying to a positive 2, but adding to a negative 3. So that'd be x minus 2, x minus 1. On the bottom, I have a GCF of 4. So that leaves me with x minus 3. And so that means that for this particular graph, there's no hole. And I have two x-intercepts, one at 2 and an x-intercept at 1. And I have one vertical asymptote at 3. So my domain would be all real numbers. I need to skip 3. I don't have to worry about the 4 there because it does not have an x with it. So there's nothing limited about the domain from that. Okay, so now I'm going to take all that information and I'm going to draw this on a graph. Again, I didn't give you guys graph paper today, so if you have graph paper at home, you can use that. If you don't have graph paper at home, then you can draw this on a blank sheet of paper and just kind of approximate what you're doing. So what I'm going to do is I'm going to go ahead and put as much of this on here as I can. So I have a y-intercept at negative 1/6. So negative 1/6 will be very close to 0. I have an x-intercept at 2 and at 1. I do not have a horizontal asymptote. I do have a slant asymptote, so I'm going to go ahead and draw that. I'll draw that in a color so that maybe you guys can see it differently. So my slant asymptote has a y-intercept of 0, and then it goes up 1 to the right 4. Up 1 to the right 4. And so my slant asymptote looks like this. Kind of worked. Okay. And then I have a vertical asymptote at 3. All right. So that's as much as you can draw without a calculator. All right. So once we get better at these, we'll have more of an idea of what things should look like. But from here, we're going to go ahead and get our calculators out and actually graph some of this stuff. And that's because that's something that we have to practice, is being able to input them, being able to get some more points, and eventually we're actually going to find some more information from our calculators. So after this, to get a more accurate drawing, I'm going to go ahead and plot this on my calculator. You can plug it in using alpha y equals if you want to plug it in like this. The bummer about doing it that way is that when you are looking for points on your graph, it's going to give you those points as fractions. And my guess is you probably don't want those points as fractions because they're a lot harder to graph. So instead of plugging it in that way, I'm going to plug it in as the top, all in parentheses. So I'm going back to the original graph, x squared minus 3x plus 2. And I'm making sure I put all of that in parentheses, and then I'm going to divide by 4x minus 12. And for the window, just your normal base window would be fine for this. And there's our graph. And if we wanted, we could actually go in and put our slant asymptote in there so that we can see it. So if I do 1/4 x, you can see that slant asymptote goes right in between there. Okay, so I can see that these 3 points are connected, and I know how slant asymptotes, well, I know how asymptotes in general work. I know that the curve is going to approach the asymptote. So I know that this one would look something like this. And then I can get some points for the other side of 3. I can look at the table and look at x values that are bigger than 3. My table's set up weird right now. Or I can go ahead and do second trace and just plug in some x values to see what I get. So if I plug in like 3.5, I get 1.875. If I plug in 5, I get 1.5. If I plug in 8, I get 2.1, just barely above it. And then that's enough for me to be able to draw the rest of the graph and feel reasonably sure that I've done a good job. So I am not looking for sketches here, I'm looking for very accurate drawings when we do this. Okay, we're going to do another example because I want you guys to be able to see one that has a hole in the graph. So this time, for our second example, we're going to do y equals x squared plus 4x plus 3. On the bottom, we're going to have 2x squared minus 2x minus 4. So for this one, we have a y-intercept of -3/4. This one does have a horizontal asymptote. So the degree is the same on the top and the bottom, and that means that the horizontal asymptote is y equals 1/2. I can factor this problem so I can see what multiplies to 3 and adds to 4, and that would be 3 and 1. And then on the bottom, before I go ahead and factor that, I'm just going to take out the GCF of 2. So if I take out the 2, that leaves me with x squared minus x minus 2. So I'm looking for what multiplies to -2 but adds to -1. So that would be x minus 2, x plus 1. So we do have a hole for this graph because we have that factor that cancels out. So the x coordinate of the hole is -1. The leftover factors are x plus 3 and 2 times x minus 2. And so that means that if I plug in -1, I'm left with 2 on the top and 2 times -3 on the bottom, which is -6. And so that leaves me with a y-coordinate of -1/3. So the x-intercept is -3. The vertical asymptote is at +2. And the domain is going to be all real numbers, but I need to skip 2, and I need to skip -1. All right, so I'm going to go ahead and graph all of this. I have a y-intercept of -3/4. I have an x-intercept of -3. I have a horizontal asymptote at +1/2. And a vertical asymptote at 2. And there's a hole at the point -1, -1/3. So left 1, down 1/3. I'm putting a point there, but I'm not filling it in. So I already know basically what this underside of the graph looks like because I know how asymptotes work. I know that the curve gets closer and closer to that line. I know that the hole has to be on the curve. And so that's what that curve would look like. And so really I just need to graph it to be able to look at the other part of the curve. So I'm going to go ahead and plug this in. I'm putting parentheses around everything that showed up on the top. So x squared plus 4x plus 3 divided by, and then I'm putting parentheses around everything that shows up on the bottom. And I'll go ahead and graph it. And then I just need to find a few points over here so that I know what the rest of the graph looks like. So again, you can look at your table. I like to do second trace and plug in specific values that I want. So if I plug in 3, I get 3. 5, I get 1 1/3. 7 is 1 exactly. And that's enough points for me to really see what's going on here.